Okay, here we go. Hi everyone. So as we record, so I'm just gonna go through questions as fast as I can, as if I'm taking the AP test. When you're taking the AP test, you don't need to show on these multiple choice tests as much work because no one's gonna check this multiple choice work. On the free response question, you have to show all your work because you have to show your thoughts. Like they're judging you based on the math logic, not just your answer at the end. Okay, so let's go ahead and run with this. F is the function given by blah blah blah. Find the maximum value of f on the interval. To find the max, we said we're going to look for critical points first. So that means when f prime of x is equal to 0. So let's go take the derivative. 3x squared. F prime of x is going to be 3x squared minus 12x minus 15. I'm going to set this equal to 0. So this is probably factorable-ish. So I see a 3 in common. I'm going to take that out. X squared minus 4x minus 5. Hey, that is factorable by 5 and 1, right? Two numbers multiplied to become 5, but subtracted become 1. X minus 5, x plus 1, okay, because the negatives have to win. And we know we have zeros at x equals to 5 and negative 1. Okay, yay! Now, to find our maximum values, I'm going to draw my little sign chart here, and we say at negative 1 and 5, we have a slope of 0, critical points. But we don't know if they are maximum or minimums. We just don't know yet. So the way we know is if the slope goes from a positive to negative, we know this is the max. Or if the slope goes from negative to positive, we know this is the min. But we don't know that yet. So what we do is we plug in values and we ask ourselves, hey, would that slope be positive or negative? By plugging a number that's say 6. If I plug 6 here, now please take a look. If I plug 6 and 6, do you see how 5 is right next to 6? That's the only factor that would matter. So 6 minus 5 is positive. This guy, of course, looks positive already. Positive, positive means you are positive, sir, in the corner here. From here on out, will always be positive. And if you think of numbers 6, 7, 8, 9, 10, this would always be bigger than 5, my only problem child, and we would always be positive. If I pick a number between negative 1 and 5, let's pick the number 0. Always choose 0 if possible. Okay, 0, no matter what, we're going to be negative here. If I pick 0, that's going to be a positive. So negative and a positive stays negative. So we're negative over here. And then anything less than negative 1, that's a negative 2. If I pick negative 2, that's going to be negative. This is going to be negative. See how negative 2 is more negative than 0? No, than 1. That means we're going to be negative. So a negative times a negative is a positive. We're going to be stuck being positive there. So we at least know we have a minimum value or a maximum value at negative 1. Yay! So this is the max. But is it a absolute max? Well, we don't know. Well, here's the problem also. That if I looked at my interval, which I didn't catch, was from 0 to 6. So from 0 to 6 over here, that's the only interval I care about. And is 5 a max or min? We said 5 was a min, right? Because it goes from negative to positive. That's the minimum value. So we know it's not going to be at 5. So if it doesn't happen in the interior, the maximum has to happen at the endpoints. So it's going to happen at either f at 0 or f at 6. So let's go ahead and plug in f at 0. If I plug in 0, 0, 0, that was really hard. That's going to be 0. And if I plug in f at 6, you know what? You don't even have to plug it in because you know the answer is going to be 6 already. Okay. Why did I say that? Oh, wait. Whoops. Maximum value. What is the maximum value of f? Whoops. My bad. Now, that is also probably a wrong statement because they ask you for the maximum value, not where the maximum was at. So again, let me go ahead and plug this in. 6, 6, 6. Oh gosh. 6 times 6 times 6 is 36, and 36 times 6 is 180 plus 36 is 216. No, 226.
Wait, Mr. Coe, if they're asking for the maximum value, wouldn't it be 8 because 8 would give you a greater number?
I don't know that. So far, if I know that if I plug in f at 0, that's going to be 0, 0, 0, right? So that's 0 here. Now, we know 5 is not going to be my maximum. So we don't have to plug in 5. But could 6 be our maximum? Yes. But they asked us what the maximum value is. So I'm thinking it's not about where it happens, it's what is that maximum value. So I need to plug in the 6 now into the problem. So I plug in 6 into x cubed. 6 cubed minus 6 times
But don't
6.
you already know where the maximum value occurs? Can't you just plug in -1?
Oh. -1 is not in the interval.
Oh, eight's
I'm
not in the
thinking that's the
interval
only
either,
way you
so
can
it'd be
get that.
6.
Yeah. Well, no, the thing is I'm trying to figure out, wait, maybe I misread this, but what is the maximum value of f? When they ask you maximum value, that's the y value. But then when I'm plugging in 6 here, I ended up with -15 times 6. That is not a maximum value. Wait, is it? No, but that's not one of my answers. Let f be the given function. Okay, what is the maximum value of the interval f between 0 and 6? Did I mess up on my factoring here? No. 5 times 1. More negatives, more positives. So 5 and -1. 5 and -1. -1 is not. How come this is not going pretty for me? Let me check something real quick. Maybe I did mess up on my
So
math.
wouldn't it be 0? Because if you plug in 6, you get a
Oh,
negative.
you are.
Plug in 0, you get 0.
Yeah, you're right. So the answer was, okay, so this was some negative, like -90, right? So this is -90, this is 0, and this is some other value that's probably lower. So you're right. So the maximum value would have actually been 0. I just didn't think 0 would be my maximum value. Because I don't believe in science, guys. I'm graphing this on Desmos real quick on the side just to make sure this makes sense. Yeah. So oh my goodness. So at 5, it actually would have been -100. So at this value here, f at 5, that would have been -100. F at 6, we said was going to be -90. Okay, that's going to be -90 here, -90. All right. And at f of 0, that's going to be 0. So which is my max of these three options? 0, -90, or -100? The answer was 0. I just didn't believe it because I was like, man, but I actually didn't mess up on my math.
And it wasn't 8 because 8's not in the intervals.
Right,
Right.
8's not in the interval at all. Well, okay, it's not 8 because they're asking, okay, careful. They're asking, what is the maximum value? The maximum value is 0 compared to -100 and -90. Okay, so it's not our x value, they wanted the y value. Okay, Bobby, question?
Yeah. So how's it 0 but not 8?
Okay, because this is our y value, and we can only have maximums at our endpoints or critical points. At the critical point we only have here is at 5, and the y value at 5 is actually -100. The endpoint on the right at 6 is -90, and the left endpoint is at 0, okay? So which of these is my largest value? 0, -100, or -90? The highest value is 0. So that's why my maximum value is 0. It is at 0.
So what was the point of finding what x equals?
The
Like
x values help
the
me.
f or the derivative of f of x.
The zeros tell me where the critical points are. And I don't know if this is a up or a down. So we realized that 5 here was a minimum value. So if they were asking me for minimums, sure, our minimum would be -100. But they asked us for our maximums. And we don't know if this was a... Go ahead.
Couldn't though we just plug in all the numbers and then whichever one's the lowest is the minimum and whichever one's the highest is the
You can.
maximum?
But then how would you know where your critical points are? How would you know where that peak is in the graph? Would you just start randomly guessing? And that's where the critical points come in. So if the critical points say, hey, I have a max or min at some value, let's say 5, and we have some endpoints, we can compare endpoint to endpoint and that 5 to figure out which one is our max or min. So we don't have to go like looking for any other values because there's no other values that will be a max till you hit a critical point. Only a critical
Mr. Cole,
point.
excuse me. Sorry.
Go ahead.
Andrew's in the waiting room. His
Oh,
Zoom was
whoops.
acting up.
Yeah, thank you.
Yep.
I left my buddy Andrew out there. Okay, f is a function given by 3x squared minus x cubed. Find the average rate of change of the closest interval for the closed interval 1, 5. Now you got to be careful about this one. This one isn't what is the instantaneous rate of change. Instantaneous means derivative. Average is f of b minus f of a over b minus a. That's what average is. Maxim, this is part of it. Okay, this is part of it. So
Okay.
f of b minus f of a. So we plug in 3 of 5 squared minus 5 cubed. Wait, well, sorry, yeah, minus 3 of 1 squared minus 3 of 1 cubed all over 5 minus 1. And that is your average rate of change. And that's a big deal. These two words, rate, sound very similar. One is instantaneous, means that's the derivative at that one point. What's the rate of change at that one exact point? And we can do that with derivatives. And average means over the whole interval. Like me saying, what's the average speed you're driving to Vegas? You take where you start and where you finished. We subtract and divide by the time. That's the average rate.
Mr. Coe, I don't think there's a 3 in front of the second one.
Oh, you're right. Thank you. Thank you for catching that. I'm just going through these way too fast. Okay, and you guys do the math for that?
This is all we have to do for the problem?
Yeah, because that's what average rate is, just like same idea of slope.
Oh, okay. And it's okay. Thank you.
Average rate is same as slope. Now, these questions here are always super tricky when they give you a graph and they tell you is 1 true, is 2 true, is 1 and 2 true, is your mother. Oh, sorry. F prime here, the derivative of the function f. So this here is given is the slope. That's a slope equation, okay? Everyone, you might want to write slope on it. Just remind yourself, hey, this is the slope. It's shown in the figure above. Which following statement must be true? Is f continuous between a and b? Okay, between a and b, because this is differentiable, can you tell me it's also continuous? First thing, if it's differentiable, is it also continuous?
Yes.
Yes, that is true. If we can take the derivative, think about it. If I have a jump here, no derivative, right? So it has to be continuous. F is decreasing on the open interval from a to b. Is it true that the original graph is decreasing? Remember, that's described as a slope. A positive slope, negative slope. So are we, f prime is negative, sorry, positive here, whoops, other way around, positive, and f prime is negative. So are we always decreasing? Answer is no.
Yeah.
See how this is all positive here? That means this is a positive slope. We've been increasing. We are decreasing from here on out, sure. The last one is f is concave down on the open interval a to b. Now, how do we get to concavity? Is we said it's related by the next derivative. So what is the graph of f double prime here? This is down, 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 down. Okay, so we stop a little bit negative to a lot negative to a little negative, but we are negative this whole time. So if you draw a tangent line, see that's negative, 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 okay?
Wait, Mr. Coe, isn't f technically decreasing the whole time? It's getting smaller.
F is increasing and then decreasing. It's increasing and then decreasing. This is the regular F graph. Does that look like concave up or concave down?
Concave down.
Concave down.
But
And
it's starting at A and it's going down.
You're right. But,
It's not the graph of f though.
right, that's not the graph of F. This is the
Oh.
slopes. So
Oh,
the slopes
that
are positive slopes, and then we have negative slopes, negative slopes.
Okay, that makes sense.
If I showed you a sign chart, the sign chart would have been positive to negative. Positive to negative.
Oh, so if it's above 0, it means the graph was positive on the original.
It's
F.
increasing, it's climbing up because we're
Okay.
gaining value. So the problem with reading these is that you have to make sure you're on the right state of mind. I'm gaining a lot of money here. This is big boom for me. Yeah, I'm making money. But I'm still making money here. I'm just not making as much money. So we're tapering off our growth. We're tapering off our growth till we stop growing. And then my stock market values go down. Okay. So to say which one of these is true, f is concave down. Yep, this is concave down the whole time because the second derivative is all negative. Okay, so these questions are tricky and they take a little bit of time to go work through.
The answer is only 3, right?
Answer is, I think it's 1 and 3 because we said
Okay.
f is continuous.
Wait, I'm confused, but it's not decreasing?
The graph is increasing. So f is increasing, yes. F is increasing, and then f is now decreasing. Why? Because this graph here is not f. This is the slope of f. This is f change. This is change of f. So if f prime is positive, that means we're growing. Growing, 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 growing. Stop growing and start losing. Maxim? Confused?
Well, I kind of get it, but it's still complicated here.
So let me give you another quick example since we are here.
So basically, we're just looking at the y, we're not looking at the x-axis.
The x-axis tells us where it happens. You're right. So if I wanted to draw a f graph to this, okay, let me ask you, am I increasing or decreasing here on my regular f graph? Going back a step. Is the slope positive or negative here? Is the derivative positive or negative? Or you're not sure? So this graph here is f.
Positive?
It's positive. This graph is my derivative graph. That means it's my change graph. It's my growing or decreasing graph. Okay? It doesn't tell me where I'm at. It just tells me how much I'm changing. I'm changing a hell of a lot. Bam, that's a big zoom. Okay? And as we get closer to this point, we start tapering off our growth. Whoops. We start slowing down our growth. After we hit our slope is 0, our growth is now negative. I'm going to start losing money and I'm going to start tanking myself. Lose a little bit, start losing more, and then start losing more, and oh my gosh, I should call the bank. Okay, and that's this idea that these tangent lines are steeper than these up here. Right? This is a little bit of falling. This is really falling. Oh, this is just forget about it. Just declare bankruptcy. And if you look at the overall f graph, this is concave down. But we can see that as this graph is negative, 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 negative. So f's prime's derivative is all negative. Okay, so this is all concave down. It's a mindset, this stuff. Okay, a table
So
of...
basically,
Sorry,
Mr. Sorry, I just wanted to ask if it's on the top of the x-axis, then it's positive. If it's bottom, it's just negative.
Yes.
So it's decreasing.
Right. So if we're talking about f prime, yes, that's correct. If it's up here, your f prime is greater than 0. That means it's a positive value. And if it's below the x-axis, this is a negative.
I see. Yeah. Okay. Thanks.
Okay. Now the table above values gives you continuous. The table above gives values of the continuous functions. They're telling me this is continuous. So 5 is linked to 2. 2 is linked to 3. 3 is linked to 6. 6 is linked to 5. Okay. If f has exactly 2 critical points on the open interval between for 10 and 14, which of the following must be true? Oh no, it's one of these. Okay. Let me shrink this if possible. Okay. So, darn, I need to squeeze that. Okay, let's double check. All right. So, which of these must be true? First question A. F is greater than 0 for all x values in the open interval. Okay, is it true that all the x values for sure are greater than 0? Okay. So, between 5 and 3, and 2 and 3, and 3 and 5, can you guarantee me that you never went below 0? Can you guarantee me that you never like ditched out of your house?
Technically not.
Technically not, yeah. So just because this, they told us it's continuous, there's no guarantee. It's not guaranteed. So this is not guaranteed. Okay. If they told me the slope was positive, or sorry, the slope was negative only. If they told me it just went straight down here. Yeah, because to get to negatives, don't we have to dip and then come back up? Right? So if you just tell me it's negative and never goes positive, the derivative, then sure. But so far, not enough information. They didn't tell me the derivative is strictly negative. Did they? No. 2. F prime exists for all x values. Is this going to be true? Can you tell me that there's a derivative for all these values? Okay. A derivative is when we ask ourselves, when do derivatives happen? Derivatives happen when it's continuous, right? And it's a smooth curve. Can you guarantee me that it's always going to be a smooth curve here between these values? Or even maybe it's not a corner here? There's no guarantees, right? It's continuous, great. Right? We never miss a beat. But there's no guarantee that you're telling me that this is a smooth curve. If it's differentiable, it is a smooth curve. No guarantees. Okay, C. Can you guarantee me that the derivative is negative for all values here? Can you guarantee me that the slope is always negative? Can you guarantee me that the slope is always negative? Wait, didn't we increase here? Aren't we increasing here? So can you guarantee me that it's always negative? Nope, you can't guarantee me that either. The last one is, can you guarantee me that f is not 0? Okay.
I guess that's the answer.
Well, I guess, but is is the slope at 12 not 0? Can you guarantee me the slope at 0 is not 0? Let's see. Slope of 12. Okay, can you guarantee me it's not 0?
Yes.
Now, the way we do this is we say f of 13 minus f of 11 over over 13 minus 11 is, so the slope is 6 minus 3, darn it, what am I doing? 6 minus 2 over 2 is 4 over 2 is 2. So the slope is positive. So that's the rate of change. Above the, if f has exactly 2 critical points on an open interval of okay, so just to say this, we have a change of values and change of values. So we have 2 critical points, something here and something here. Right, so one thing I want to say here is that they told us we had 2 critical points. Now where could these 2 critical points have happened? A critical point happens when we have a sign change from positive to negative or negative to positive, right? That's when our sign changes. So I want to tell you where those critical points are going to be right now. We grew from 5 to 2, right? No, sorry, we decreased. Didn't we decrease from 5 to 2? And then we increased from 2 to 3. So we have a critical point someplace over here. It might be at 2, it might be next to 2, but someplace in the area. Cool with that? From 3 to 6, we increase, and then we decrease again. Okay? Is that right? We decrease.
I think you drew the lines the wrong way.
Oh my gosh. Oh yeah, this last one is the wrong way.
And the 3 to 6.
3 to 6 we increase. Oh my gosh, what am I doing? I'm just jumping around here. We increase, and then we decrease. Okay? So where would the next critical point be around?
Around 6.
Around 6. Okay, cool. That's my next critical point is around 6. So if we have 2 of our critical points already taken up, they're telling me that is this true, is that there is no critical point at 12. Where my critical points are? My critical points are around 11 and 13, right? So there is no critical point at 12. So this is not 0. It's true, it's not 0, it's going to be negative. Or it's going to be positive, sorry, positive. Okay. So that's the idea behind this. Okay, let's do the next one. When x is equal to 2e, find this limit. Do you guys remember how to do limits? Yeah. So here is the trick. Does this look familiar to us? This is just the definition of the derivative for what? F. What's my f of x? Can you guys tell me what my f of x is? Give me a guess. Okay, so the trick is this. See how that's f of x? That's your f of x. That's your f of x. Are you guys okay with me just saying that's f of x? Instead of having to do the difference quotient? Now what's the derivative of ln of x? It's just 1 over what? 1 over x, if you remember. Anyone remembers this? Okay. And then now what is f prime of 2e? It's just 1 over 2e. And that's really the fast way to do this problem. To remember that this is just the derivative equation of what? That's my function back here, my original. So we just take the derivative of that.
So 2e is similar to ln x?
No, the ln of x is we first take the derivative and then we plug in the 2e at the very end.
Oh.
Okay. Unless if you want to remember how to combine logs. If you're subtracting logs, you're dividing logs, FYI. Okay.
Wait, can you do that again?
Sure. So the trick for this
kinda
problem is
lost.
whenever you see this difference quotient equation, as the limit goes to 0, that's the derivative. That's just the definition of a derivative. So if you notice that, hey, that's just a definition of derivative, that's your function. That's your function. What's the derivative of that function? The derivative of ln of x is just 1 over x.
How come you just ignore the rest of the equation?
Because this here is really just asking us for the derivative. That's a fancy way of asking for the derivative. This difference quotient was really the slope formula. We described it in 2 different ways. We said it could be f of x plus h minus f of x over x plus h minus x. And if you take a look here, the x's cancel out. And that's just f of x plus h minus f of x over h. And as a limit, as h goes to 0, this was defined as slope. And the slope is just the derivative. So on our first chapter test, we did a lot of this. And then once I taught you guys how to do derivatives, you guys said, why didn't you just tell me to just take the derivative using quotient rule or product rule or power rule or any of those identities?
But what about the rest of the equation, like the ln x plus h?
Again, all that stuff is replaced by saying this here is just the definition of the derivative. So that's just take the derivative to save ourselves some time.
So during the test, how do we recognize that we're just supposed to do that?
Yeah, because you're supposed to recognize that's the definition of a derivative. If I wrote limit as h approaches 0 of x plus h squared minus x squared over h, what do you think this is the derivative of?
X squared.
Yeah, it's just the derivative of x squared.
Oh, because you always plug in f of x to the last part of the equation, right?
That's always f of x, right? That's always f of x. So you can see this
That makes
is my
more sense.
upgraded version. That's my normal version. Upgraded version, normal version. My x plus h version versus my regular x version.
I actually see no logic why it works like that, but if we should remember.
Okay, so let me go ahead and do this problem over here. This one's easy to do, okay? So that's the same format. If I write out x squared plus 2xh plus h squared minus x squared over h, the x squared subtract out, and then remember how we divide all the h's gone? So we have limit as h gets closer to 0 of 2x plus h. As h goes to 0, 2x.
Yeah, I see like this.
Okay, this is an easy one, right? But if you want to do it
Yeah.
for logs, I'm not sure if I can do it though. Let's try it. If I do ln of x plus h minus ln of x, if you remember, if I'm subtracting logs, I'm actually dividing logs. So let's do natural log of x plus h over x over h. Now, limit as h goes to 0. Now, I can't remember how to get rid of this log problem. Maybe, oh yeah, natural log of, no, you can't separate the plus. So this would have been natural log of 1 plus x over h. No, we can't do it. We have to find some other way of doing this. Okay, so the problem is, you get stuck here and you're like, crap, how do I divide the h's? And you can't. It's because this is just, by definition, the derivative of natural log of x. Okay, this format here is just the limit version of us just taking the derivative. If I wrote this problem, limit h gets closer to 0 of e to the x plus h minus e to the x over h, you're going to be, how the hell am I supposed to combine e to the x plus h and e to the x? And the answer is you don't. You just take the derivative. Whoops. You just take the derivative of e to the x. Okay. All right. Find f is differentiable function here. What is dy dx when x is equal to 3? Oh my gosh, this part didn't print out. Image source formula, blah, 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 style, vertical. Well, okay, whatever. Okay. F is differential function. And so that means we can do chain rule on this, okay? So the derivative of sine is cosine. Leave the inside alone. Times, go ahead and move on. We take the derivative of f prime, leave the inside alone. And then plug in the derivative of inside is 2x. When you plug in 3, it'll be cosine f of 9 times f prime of 9 times 6. Oh, 6 f prime 9 cosine f of 9. So this is your answer right there, D. Yeah. Read the code. These are left.
Wait, how did you get this formula?
How did I get this here, or how did I get this answer as D?
Like, how did you know that we need to multiply them? The
Okay.
cos f9 and
So they said what is dy dx? Derivative, right? So when I take the derivative, we have to do chain rule.
oh yeah,
So when I do chain rule, what do we take the derivative of first?
cosine.
Yeah, it becomes cosine, right? Leave the inside alone.
Mm-hmm.
Once we're next level is take the derivative of f. That's f prime. Leave the inside alone. And then what's the derivative of x squared is 2x.
Oh, okay. Oh yeah, I see.
And then plug in the 3. Now this is why the AP test is more confusing, because they don't just say take the derivative of dy dx. they give you a situation. The situation is we have a differentiable function. You can take the derivative. You can take the derivative of f, so that when you take the derivative of f, you get f prime. Okay. All right. Taking the derivative of this, we need chain rule. Okay. So we take the derivative of 7 first. Leave the inside alone. And then you multiply by the derivative of the inside. Uh-oh. Okay, there it is. The answer. Okay. Okay, this one is a little bit different. They want us to go ahead and try plugging it in, maybe. So ln of x minus ln of 3 over x minus 3.
Mr. Ko, could you scroll up a little and show so we could keep the work from the last problem?
Oh, well, yeah, sorry. I mean, you could do this one yourself. That I just went over the rough part of it.
Yeah. All right, that's all. Thank you.
Yep. Now, this one here is, if I plugged in the 3 in, right? Plugging the 3 in, this would have insta-failed us. And then this is the limit x approaches a of f of x minus f of a over x minus a. Okay. Now let me ask you, what is this representing? Okay, what is this representing? If I plug in f, isn't that y minus y over x minus x? So what does this represent?
Slope.
Slope. Are you guys cool? This represents slope. If I plug in 3 here, and if I plug in 3, if I plug in a, if I plug in a, isn't that exactly the same point? So how far are these 2 points away from each other?
1.
Well, they're nothing, right? They're infinitely small. So isn't it just the basic idea of a derivative? This is just the derivative. Take the derivative. The derivative of f prime of x is 1 over x. And then x value is 3. Plug in 3. This was our alternate way of writing a derivative. Remember, this was our x minus a approach.
Can we just realize that they want the derivative?
Yeah. Yep. That's the whole point about this. It's just the
Right.
derivative. They might ask you actual limit questions, sure, but this here is just the definition of a derivative. Okay, just remember, this is y minus y over the same x's. That's slope. That's derivative. Instantaneous rate of change. Okay, the next problem is just quotient rule. Do you guys need me to do quotient rule? You guys got quotient rule? You got this?
It's just front back minus back front.
Yeah.
Right. And then over the bottom squared.
So instead of front, you would use top and bottom. Yeah. Okay, that's a 9. That's a 9. Uh-oh, a Saucy Triangle. Okay, this looks like it's going to be a wordy one. And a Saucy Triangle, a Saucy's right triangle. So a Saucy's right, we know this is 90 degrees. With legs length and area is, they give us area 1/2 s squared. At the instant when s is equal to the square root of 32 centimeters, the area of the triangle is increasing. Now here's a trick. Area of the triangle is increasing. What the hell does that mean? Is that just A? Area is increasing is the change of A. That's dA over dt. Okay? That's change of A. And this is changing at 12 square meters or centimeters squared per second. So that's a rate, and that's the gimmick here. You read the problem and you see, oh, it's at a rate. Oh, that's a derivative. So I'm looking for dA dt. At what rate is the length of the hypotenuse of the triangle increasing? Oh crap, the length of the hypotenuse is increasing. Okay, so they want me to find dH over dt. Oh my gosh, how am I supposed to get to dH dt? At what rate is the length of the hypotenuse of the triangle increasing? Oh my goodness. in centimeters per. Okay. So they gave us a couple things. They said A is equal to 1/2 s squared, right? That's given over here. Now s are these sides here, and this is my hypotenuse. So we can do one of two things. We could first go ahead and take the derivative of this, or you could convert s to h right now. It's up to you. Do you want to convert s to h, or you want to just take the derivative here? If we do take the derivative, we need to convert ds over dt to dh over dt, because that's what they want us to solve for. So I'm more inclined to change it now. Is there a way for us to relate s and h in this 45-45 90-degree triangle?
Pythagorean theorem.
You can do Pythagorean theorem, but if you remember, this is a special right triangle, and this would be square root of 2. This would be s square root of 2. H is equal to s square root of 2, and if you do Pythagorean theorem, you would end up with square root of 2. If you remember, it's going to be s squared plus s squared equals to h squared, right? And then if I is 2s squared equals to h squared, take the square root of both sides, h is equal to s square root of 2. Okay, always true. So what I'm going to do is I'm just going to plug that in. Okay, but I'm going to solve for s though, because we're so far solving for, we need s, so you can plug it in if you want, but I'm going to move this over. So s is equal to h over square root of 2. You guys feeling okay with that? S is square root of 2. Rewriting this, a is equal to 1 over 2, parentheses, h over square root of 2 squared. I'm going to get rid of this square root of 2, kick it out. A is equal to 1 over 4 h squared. Yes, so I decided to break up so Lena asked if we're going to have word problems. Yes, I'm going to break up the final into two parts, the easy part and the harder part. So the easy part will be on next Tuesday coming up. Will be stuff at multiple choice type questions. And the harder part will be only like three questions, maybe at most 4 if I'm pushing it, right? But those will be the application questions. Like this is like an application question. So we take the derivative of this, which would be the derivative of a is dA over dt. And the derivative of this guy here, careful, h squared is going to be 2 over 4 h dH over dt. Now for all our related rates problems, if you guys have been working on them, is we have to now plug in everything we know. We know dA dt, yes we do. We're looking for dH dt, and we only have to plug in h. Well, they gave us one extra special value. Didn't they give us s is square root of 32? If s is square root of 32, h is equal to square root of 32 times square root of 2 is square root of 64, which is 8. H is 8. So 12 is equal to 2 over 4 times 8 dH over dt, and then we can solve the rest. 8 times 2 is 16, 16 divided by 2 is 4, 12 divided by 4 is 3, equals to dH over dt. For this one, I would say do the questions you can do on the PDF, and then when you have time, go back to the browser, and then you can plug in your answers. So turn on the Authenticate browser, you can plug in the answers there. And you can see how you did. You can go ahead and see how you did. Make sense, Alejandro?
So, Mr. Ko?
Yep.
On the test, how do we know to do all this?
It's because they asked us some things that we weren't able to just right away say. They asked us, what is the rate of the length of the hypotenuse, right? So that's dH dt. That's a rate. So we know these are rate problems. So they also gave us, right here, we said that was rate of the area. So that's dA dt. So how to get from basic A and S to a rate problem? We just take the derivative. Right. Emily, this is a place to warm up, because all this stuff is what you're going to be kind of responsible for. So if you can answer these questions, these are the topics that will be on the final, yes. Okay, Let f be a function defined by this weirdness. What is the largest open interval where the graph f is concave up and increasing? So this part is very tricky. We're looking for not only is it concave up, but we're also looking for when it's increasing. So how do I tell a problem is concave up? That's the second derivative. How do I tell something is increasing, decreasing? That's the first derivative. So we're going to take the derivative of them. We're going to take the couple of derivatives. So f prime is equal to 12x minus 6x squared. So let's find the critical points here. The critical points are, that's going to take 6x. It's going to be 2 minus x. How do you feel about that 2 minus x? Double checking. So we have two zeros. X is 0 at 0 and 2. On my graph, f prime, we have critical points at 0 and 2. Now, when is this graph increasing and decreasing? Well, go ahead and plug in values quickly. If I pick a number that's really big, really positive, positive and positive here are stay positive. If I pick the number 1, if this is 1, this is positive and this is still positive. Is that right? Positive and positive? Oh no, I made a mistake. If I pick a number that's really negative, really positive, that becomes negative. I'm sorry. What am I doing? This is negative, this is decreasing. My mistake. If I pick 1, that's going to be positive and positive. If I pick something that's super negative, that's going to be negative, and this is going to be super positive, that's going to be a negative. So when is this graph increasing? It's increasing between 0 and 2. Okay, that's when it's increasing.
Don't we know that it's concave down too by that?
We actually do not know, because right here, it's cubed, so we don't know concave up and concave down.
But if it wasn't cubed, we could tell it was concave down from that, right?
Yeah. So
because it would be negative, positive, negative.
So here's the thing. Yeah, so you can tell this is concave. Oh, sorry, this is concave down to up. That's concave up, and this is concave down. But you don't know when it switches. And that we don't know when it switches. We know what happens. We just don't know when it switches. That's our next derivative. Let's go take the next derivative. F double prime is 12 minus 12x equals to 0. Make that equal to 0. And we know it changes that. Wait, what? Okay, it changes at minus 12 to both sides, minus 12. X is equal to 1, positive 1. So at 1, let's draw my next concavity, F double prime. At 1, we know it changes from which way to which way. I don't know. So we're going to plug in values on the right, plug in values on the left. Looking here, if I pick a number that's too big, this is going to be negative, and this is going to be positive. So at what interval is this going to be not only concave up, but also increasing? So if you notice, I drew two graphs. At what interval is it going to be concave up and increasing? Well, isn't it concave up?
1, 2.
0 to 1.
0 to 1.
Oh.
Because not only is it concave up, but it's also increasing only between 0 and 1. Okay. Sure, it's increasing from 0 to 2, but I'm not counting anything past 1 because it's not concave up anymore. So everyone see where it's overlapping? So from 0 to 1. You guys want to save the world? Learn some calculus. Super critical thinking. If you want to argue about nothing, go get a political science degree. Shoot, this is being recorded. Shoot, never mind. Sorry. Okay, so this next problem is, we're trying to shoot off to infinity, right? Is this a graphing, non-graphing? I don't remember this calculator, non-calculator. Now, I can't plug in, okay, so if I plug in infinity here, that's going to be infinity. And if I plug in infinity here, now what's natural log? Natural log looks like that. So where does it go? Exponential is natural log. So if I plug in e to the infinity here, that's infinity, plus infinity, that's infinity. And so this is going to be infinity over infinity. Okay, how do I know that? How do I know this? Okay, I did it on my brain. Not really. So if I plug in infinity here, isn't that just infinity? That doesn't help me. And if I plug in e to the infinity, that's infinity plus infinity is infinity. And natural log, look at this graph. See how this eventually shoots off to infinity? That's infinity also. So we're infinity over infinity. And we have a special rule that when we have the limit of infinity over infinity, we do something to make this problem easier. Do you guys remember what that is? If it's infinity, infinity, or 0 over 0. It's called L'Hopital's rule. And L'Hopital's rule says, if it's 0 over 0, or infinity over infinity, you crapped on yourself, and instead just take the derivative. The trick is just take the derivative of the top and take the derivative of the bottom and try again. And that is L'Hopital's rule. If it's 0 over 0, infinity over infinity, take the derivative. 1 over e to the 3x plus x times, chain rule, the derivative of e is e to the 3x, chain rule times 3, plus 1 over 1. So L'Hopital's rule says, take the derivative and then try again. So I took the derivative, and now we're going to try again. Now, what is 1, sorry, we're going to plug infinity again. What is 1 over infinity? That's just 0, isn't it? No, sorry, 1 over infinity is 0. Yeah, this is 0. So 0 over 1 is 0. Now I'm going to graph this on Desmos. Oh, dude, it's going to take me forever to write that. Never mind. But trust me, it's just 0, I think. The natural log of e to e to the 3x plus x all divided by x. Oh, wait, what? No. Wait, where's it going? No, answer is 3. What? Uh-oh. I made a mistake. I should have not said this. Oh, gosh. Answer they say is 3. Why is it 3? Let me see. I said 0, but e to the...
Do the e's cancel out?
I was...
All you're left
Well,
with-
because of this on the bottom here, it doesn't really, right?
Oh yeah, there's an x.
And then, why is it just 3? I must have messed up then. Wait, did I write it correctly? 3x plus...
Do you have to division rule, quotient rule?
Well, no, what happens is when we're doing L'Hopital's rule is take the derivative of the top and take the derivative of them separately. So we end up with this problem here. Well, okay, so that's actually okay. Look at it again. Limit as x approaches 0 of now e 3x times 3 plus 1 over e to the 3x plus 1 plus x. And this is back to infinity over infinity. Fail, Mr. Co. Go away. I just rushed into it. Okay, let's try it again. Take the derivative again. It'll be e to the 3x, okay, times 3 plus 0 over e to the 3x times 3 plus 1, okay? And again, this is it. If I plug it in, it's going to be infinity over infinity, right? Because that plus 1. So we're at, again, round 2. This is 9 e to the 3x over e to the 3x times 3 plus 1, okay? That's infinity over infinity. We do it again. It'll be 9 times e to the 3x times 3 over 3 e to the 3x times 3 plus 0. Now we can divide the e's, divide the 3's, and that's going to be just 3. I hate myself. So this L'Hopital's rule, you needed to do it several times to get the answer 3.
How'd you get rid of the plus 1?
What's the derivative of this again?
0.
That'd be 0, right? So what happens is we took the derivative repeatedly to top and bottom because it follows L'Hopital's rule of 0, 0, or infinity or infinity. And this was still infinity over infinity. So we just decided to go again at the problem. Man, these questions must have been the tricky ones. And the answer is 3. Okay, let's see. Given this problem here equals to 4, what is the derivative? Okay, so this is derivative implicit differentiation. That means we're just going to take it as it is. If you want, you can take a derivative d over dx to both sides. So let's go ahead and take the derivative of d to dx for all these sides. The derivative of 3x is 3 dx over dx. So that cancels out. The derivative of tangent is secant squared y dy over dx. And the derivative of 4 is 0. Remember, we do chain rule. Derivative of tangent first, leave the inside alone, and then derivative of y is dy over dx. Now what they want us to do is they want us to solve for dy dx. So you're going to get rid of the 3 and then get rid of the secant. Now they wrote this in a funny way because this is negative 3 over negative secant squared y becomes a positive, and then secant, they moved it to the top because the reciprocal of secant is 3 cosine of y. 3 squared. Yeah, at the time, I'm sorry. But you guys, okay, I'm going to stop now.
Bye, Mr. Cole.
Bye, guys.
Mr. Code.
Okay, next problem is plugging in 0. Let's go ahead and try plugging in 0. If I plug in 0, it's going to be 0. E to the 0 is 1 minus 0 minus 1. We see that's 0 over 0, so we use L'Hopital's rule. L'Hopital's rule is simply just, hey, if it's 0 over 0, that doesn't make any sense. We go ahead and just take the derivative. The derivative is, on top, it's going to be 8x over derivative of e to the 4x is just e to the 4x, chain rule, times 4. 4 e to the 4x minus 4, okay? And that's our chain rule. We're going to plug in 0 again. We end up with 0 over 4 minus 4, which is back to 0. Darn it. So we have to do L'Hopital's rule again. So limit as x approaches 0 is going to be 8 over the derivative of e to the 4x is e to the 4x times 4. So it's 16 e to the 4x. And then we can plug in 1 again, or plug in 0 again. So it's 8 over e to the 0 is 1. 16 is 1/2. Okay, L'Hopital's rule. G is a twice differentiable function. They give us a couple points here. Great. What is the following true? What is this? The following must be true. So since they gave us our 2 points, they're probably talking about slope here, as you can see. Or the second derivative. Oh, concavity. Oh, I don't know about that. But we have our rule for average rate of change. So that's our average slope. And if that's our average slope, always exists someplace in the graph. So let's figure out what our average slope is. So it's going to be g of 10 minus g of 0 over 10 minus 0. We see that g of 10 is 220 minus 20 over 10 minus 0 is 200 over 10 is just 20. Okay. So for sure, someplace in this graph has a slope of 20. Right? So someplace in the graph has that common slope of 20. And that's what we're told is that we have some common slope 20 for some interval in t. Someplace along the way we have that slope of 20. For t is greater than 1, the position of the particle is moving along this axis. At what time t is instantaneous velocity of a particle equal to the average acceleration of the possible. Okay, so this was our mean value theorem, that we expect that an average value should exist someplace along the graph. So let's go ahead and figure out what that is. P of 16 is equal to square root of 16 minus 2. So that's 4 minus 2 is 2. And P at 1 is square root of 1 minus 2 is a negative 1. Okay, so because 1 minus 2 is negative 1. And the average rate of change is 2 minus negative 1 over 16 minus 1 is 3 over 15 is 1 over 5. Okay, that's my average rate of change. Now we're trying to figure out at what actual point for time t, blah, 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 at what time t do we have that same instantaneous rate? So instantaneous is the derivative of t, whoops, which is equal to, derivative of this is 1 over 2 square root of t. When will this equal to 1 over 5? And let's go ahead and multiply these around. If only you can flip the 2 square root of t is equal to 5. And then divide by 2 square root. Divide by 2 and square it. T is equal to 5 over 2 squared, which is 25 over 4. Okay, a particle moves along the x-axis, and here's our problem. What is the time t at the velocity which the particle is 0? Okay, so when would the velocity be 0? We just take the derivative. 12, okay, the problem is, take a look at this derivative. It's two different functions. We need to do product rule. So 12, and then derivative of the front is e to the negative t times negative 1 sine of t, plus the derivative of sine is cosine of t. Leave the front alone, e to the negative t. And we're going to try to make this equal to 0. Now, so at what time does t velocity of particle goes to 0? So I'm going to go ahead and factor these 12 e to negative t out, and we're left with negative sine of t plus sine of t, cosine of t. Right. So our idea is that either this will go to 0 now or this will go to 0. So when does e to the negative t go to 0? It actually will never go to 0. And at what sine and cosine would these actually cancel out? If you remember your unit circle, sine and cosine have the exact same value at pi over 4. Okay, pi over 4. So the answer is pi over 4. This question is just going to take the derivative. Careful, this is product rule. Number of gallons in a storage tank. Okay, this is looks like a rate problem. I hear the word rate. So this is the number of gallons in a storage tank between 0 and 5. At what rate is, in gallons per minute, is the amount of water in the tank changing at time t? So they want to find out what dw over dt is. Okay. What is the rate of gallons per minute? They're looking for dw dt is the amount of water in the tank changing at t is equal to 3. T is equal to 3. Okay. Okay. So what the number of gallons in the storage tank at time t is multiplied by that. So that's the number of gallons. At what rate is the gallons per minute is the amount of water in the tank changing at t is equal to 3 minutes. So okay, so if I take the derivative of this straight, it'll be just w over dt is equal to 25 cancels out, so we're left with negative 2t dt over dt. What happens with dt over dt? Those go away. So to solve for dw over dt, is just plug in the only variable here, t, which is 3. Negative 2 times 3 is negative 6. That's our rate at which the water is increasing. So this one problem was actually a little easier because the variable that they gave us t was actually our rate. So cancel it out. The positive variable p and c can change with respect to t. The relationship of p and c is given by this equation. So p and c are not a constant. At instant when dp over dt and c, okay, so they give us pretty much kind of everything that we kind of need ish. But let's go ahead and see what's going on. So if we take the derivative, it's 2p dp over dt is equal to 3, 20 minus c, careful, right? Remember that's chain rule, times the derivative of 20 is 0, and derivative of c is negative dc over dt. Yes, you have to keep that negative sign. So in order to solve for this, they gave us, let's look at the problem stuff they gave us. They gave us this, they gave us our c value. They didn't give us our p, so we actually have to go back and solve for that. P squared is equal to 20 minus 15 cubed. See, they gave us our original p equation. So p squared is equal to 5 cubed, and so p is equal to the square root of 125. 125. And that is 5 square root of 5. That's our p-value. So now we have our p-value along with that. So we have everything we need to solve for dc dt. So just to help you plug that in, 2 times our 5 is 10, square root of 5 times 41. We're going to go ahead and divide out this over. So we're taking the 3 and the 20 minus 15. Remember that we said that was 5, right? We said that was 5. And we're going to take out our negative sign with us. And that's our dc over dt. And that's this guy. Okay, 21. They asked us to take the derivative, dy over dt. This is implicit because we have x's and y's, so let's go ahead and do that. 2x dx over dx plus product rule dx over dx y times dy over dx, leave x alone, minus the derivative of y is 3 dy over dx equal to 0. Okay. And now for these questions, you guys can simplify the dx over dx. These go away, right? Those are nice. And then we have to solve for dy over dx. So isolate those by factoring, and then we're going to push stuff over. You could also just plug in the 2 and the 1 right now to save ourselves some time. And if we do that, that's going to be plug in 2 is 4, plus plug in 1, which is 1. dy over dx, we don't know what it is. That's what we're solving for. The x value we said was 2. And then 3 times dy over dx. I'm going to move the 4 over to the other side. And I'm going to factor out the dy's here. I'm going to divide dy over dx. We're left with 2 minus 3 is equal to negative 4. And that's a negative 1. Move it over. That's going to be dy over dx is equal to 4. Let f be the function defined by this here. Approximately, what is the approximation for f10 found by using the line tangent? Okay. So why did they choose 10? It is because 9 plus 1 is 10. And we know what whoa, shoot. That was a cube root, never mind. We know the cube root is 8. 8 plus 2, yeah. 8 plus 2, yeah. The even total is 8 plus 2, right? Whew, scary. So our equation for our approximation, f of 10 is equal to f at 8 plus f prime at 8 times the difference, or the delta x, the change, and the change in that would be 2 spaces, okay? 2 spaces away from the slope. So f at 8, we know it's going to be 2 because the cube root of 8 is 2. The derivative of f is 1 over 3, and then it's going to be the x to the 2/3, right? Because it's x to the 1/3 power. If we subtract 3 over 3, we end up with 2/3 on the fraction. So plus 1 over 3. I'm going to write the cube root squared. Okay, and then times 2. And we can write the 2 on top. If we plugged in our value x we said was 8. The cube root of 8 is 2, and 2 squared is 4. 4 times 3 is 12. So it's 2 plus 2 over 12, which is 2 plus 1 over 6. They want us to write a common denominator, so it's 12 plus 1 over 6, 13 over 6. Let f be the function approximate this value found by using the tangent line at pi over 2. Okay, great. Pi over 2 is... Okay, pi over 2 is 3.14 divided by 2 is 1.57. So that's what they're going to approximate, 1.57 to 1.5. Okay. So our rule again is f of 1.57, which is pi over 2, okay? Then we're going to add our derivative, which is f prime, at 1.57, and then we're going to subtract our 1.57, oh, 1.5 minus 1.57, and this is actually going to give us a negative value, because we're going to go back a little bit, negative 0.07. So a couple of these things, we can take the derivative pretty easily. The derivative of 2 cosine f prime is going to be negative sine of x. If we plug in pi over 2, the cosine of pi over 2, if you remember, at pi over 2, it's going to be 0. Okay, if you look at a unit circle, pi over 2 is up here, the cosine is 0, right? 0, comma 1. So it's going to be 0 plus the derivative. The derivative of sine here, okay, is, what is the derivative of sine? Derivative of sine is, sine at pi over 2, plugging pi over 2 is 1, so it's going to be negative 2. And the difference here is, find the approximation of 1.5, the problem, and then slope is negative 2, and our difference is negative 1.07. Is that what they wanted? Well, not 1.07, just 0.07. A little confused about this part. 0.07 negative, right? Let f be the function given here. What is the approximate for 1.5 found by using the tangent line to the graph of f at pi is equal to 2? Yeah, pi is equal to 2. The sine of pi is equal to 2 is 1. Negative 2. The cosine at, what is f? Oh, sorry, this is a 1 here. That's a 1. Because 2 cosine of pi over 2 is 0. 0 plus 1 is 1. That's a 1. So 1 plus 0.14. So I guess we're about 1. Okay. Cosine. Okay. Let f is a function given by f of x is equal to e to the blah blah. Find the equation of a tangent line of the graph. Okay, so if the tangent line is y minus y1 is equal to m x minus x1. So we need our point x and y. They did give us our x and y point. Our x y minus 3 ln of, y minus 4 is equal to x minus 3 ln of 4. And then they want us to find the derivative, which is e to the, so f prime is equal to e to the x over 3 times 1 over 3. So it's going to be e to the e over 3 x to the 1. It's x over 3, sorry. Okay, if I plugged in the number 4, so, now we're going to plug in e to the 3 ln of 4 over 3 over 3, because we're plugging what is f prime at 3 ln of 4. We're plugging our x value to find the slope. These cancel out, leaving me 4 over 3. That's 4 over 3. So our answer is here. Okay, 25. They want us to take the... they're given the first derivative. They want to take us all the way to the third derivative. Okay, fine. D squared y over dx squared is 4x cubed minus 6x squared plus 3. Our next derivative, using all these are power rule, it looks like, is the derivative of this, which is 12x squared minus 12x. Then it wants to plug in 2. 2 times 2 is 48. Sorry, 4 times 12 is 48. And then 4 times 2 is 24. 24. Okay, the next value is take the derivative and plug in 2. Easy peasy. The derivative of this is 1 over, be writing this as x to negative 1 plus 5x minus 1. So let's take the derivative. This is negative 4 over x squared. That becomes a negative 2, right? Minus 1 is negative 2. And the derivative of 5 is just 5x is 5. Plug in 2 is negative 4 over 4 plus 5 is 4. Okay. Next one is just take the derivative. Derivative of this is cosine, leave the inside alone, times the derivative of the inside. And then they want us to plug in our... That's the derivative. Plug in our square root of 2 pi. All right, sure. Cosine square root of 2 pi squared plus pi, and then 2 times square root of 2 pi, which gives us, that cancels out, leaving us 2 pi, this is on the square root, right? So that's just 2 pi plus pi, and then 2 square root of 2 pi. And that's going to give us 3 pi times 2 is 6 pi square root of 2 pi. Oh my gosh, that's not one of my answers. What did I mess up here? Derivative of sine is cosine, yeah. Leave that alone. Derivative of this is 2x, got it. And then we plug it in. These are pi's here, I think, right? These are pi's. It's 2 pi plus pi is 3 pi. 3 pi and 2 should add to be 6. Oh my, wait, Take the derivative and then plug it in. Take the derivative and then plug it in. Take the derivative. Take the derivative of this guy is cosine. And that's 2 chain rule. And then plug it in and see what happens. Oh shoot, this was still cosine. Oh my gosh. So lame, Mr. Co. This was still cosine. It's still cosine. I was wondering what was going on. The cosine of 3 pi, if you remember what the cosine of 3 pi is, here is 0, pi, 2 pi, 3 pi. That's going to be a negative 1. So this cosine of 3 pi is negative 1 times 2 square root of 2 pi is negative 2 square root of 2 pi.